Okay, I think we'll just make a start then. Iona, I think if other people join us in the next few minutes, then that's fine. So if we just move on to the next slide. So just a reminder of just what Iona said, if during the presentation, if you can keep your camera and your mic off and your mic on mute, it just stops any feedback. We are using PowerPoint Live today, and if you've attended any of our previous sessions, you'll already be familiar with the accessibility features highlighted on the screen. Just briefly, you can navigate the slides using arrows, and you can use the drop-down menu to use the full screen facility and to turn on live captions if you find it helpful. During the session, you can make comments and ask questions using the chat function, and also towards the end of the session, when we finish recording, there'll be an opportunity to take part in a little bit of a discussion. At that point, we'll invite you to put your hand up and come in and ask questions and put your camera on. If you're having problems with either the sound or accessing the chat or viewing the slides, in the first instance, we would just recommend that you leave and rejoin, as this usually fixes the problem. And finally, you'll see a take control button at the top of your screen, and we'd ask that you please don't click on that, as this will cause probably everybody to lose access to the presentation. So, as I mentioned, if you'd like to ask a question this afternoon, you can post it into the chat, or at the end of the session, you can use the hands up and come in and speak to us. But sometimes there might be a question you want to ask out with the session about the programme in general. So if you haven't already had the opportunity to join the team, then we'll put some instructions here on how to go about doing that. Now, this is a Microsoft team on Glow, so you will need your Glow credentials in order to join the team. There's also a welcome pack, which everybody that's here this afternoon should already have, unless you registered with us today. There was one person who registered with us today, so if you're here this afternoon, we haven't sent you out the welcome pack yet, but you will get that, which gives you details of how to join the Microsoft team and how to access all the other sessions in the programme. There's also some drop-in sessions which we hold in the team, and more details of the upcoming dates for those will be sent out to everybody on the contact list in the next few weeks. Remember, this team is your space. You can post questions on there for us. We will monitor it and we'll get back to you. But you can also post questions on there for each other. If there's something that you think you want to find out about what your colleagues have, how they've approached something, then please feel free to just post that in the team. It's your space to use. And there's no daft question. If you're asking it, if you're thinking it, you can guarantee there's somebody else out there thinking the same thing. So the team's there for you to use, and we would encourage you to make good use of it. Okay, so just a little bit of an icebreaker. Let's think about how you're feeling today, and to check out that the chat function is working for you all. What we'd like you to do is to have a look at the emojis on the screen and type into the chat which one best describes you this afternoon.
Should be able to click the emoji when you type a new message. There's an emoji option. You should be able to select from those, and please feel free to pop it in the chat. I think we know which one Jenny might be feeling. Yeah. So we, apologies on that. Oh, we've got a couple of smiley faces. That's excellent.
Great.
Yep.
And there's Jenny. The yeah, that's what we were expecting.
We need a sympathetic emoji to send back to you. Unfortunately, it's quite a long list of emojis. It might take a while to find the very one that you need.
That's okay. We're going to you perfectly.
Give you some time. very positive today.
Everybody's very smiley this afternoon. Oh, no, somebody else not feeling too good.
Somebody else has got germs. That's a pity. Oh, Jings.
Mr. Parkinson, I want to know what you've been up to today.
Still on Christmas break mode, maybe. I don't know. Oh, that's nice. Like the high five. Excellent. Good. That might be just about everybody, I think.
Great. So everybody's got access to the chat. We're all working well and we're ready to go. So for those that attended our first session, the introductory session, we shared at that point a bit of background and our reasons for offering the programme of live sessions and workshops this year. And you can see these here. So we're just sort of revisiting these, but what we specifically want to emphasise is that this is really a safe space for us to explore effective approaches to learning, teaching and assessment within numeracy and mathematics. And we hope that this will give you a chance to reflect on and to strengthen your own practice. And as I said before, remember there are no daft questions. Please feel free to put a comment into the chat or a question into the chat and we'll address it as we go through this afternoon. So as you can see from this slide, today's live session is going to focus on aspects of mathematical reasoning, how it fits within the curriculum, and we're going to explore some activities and approaches which will help learners to develop their mathematical reasoning skills. So just to get us beginning to move on to some suggested activities. This is an image taken from the Same But Different Maths website. The link's on the slide, and as we said, it's Microsoft Live, so you can click directly onto it, but you can also access all the links through the thing link after the event. So it's important when you first start using tasks like this that you give your learners some guidance on how to approach them. So the website provides a really useful 6-step protocol. So it suggests that you start off by showing the image and posing the question. So there are 2 images. How are these 2 images the same but different? So then give your students some time to think on their own, just for a few minutes. And next, you might have your students then turn and talk to their shoulder partner and share their ideas. And they could do this orally, or they could record some of their ideas on a mini whiteboard, for example. Next step then would be to bring the whole class together and have a whole class share. So have the students share their ideas and how the 2 images are the same but different. You could consider writing the ideas up on a chart with one side for same and one side for different. It's important that this is done publicly, so that we're gathering all the ideas into a mathematical forum. Next step would then be to summarise the students' ideas, clarifying what we now know about both the images that are the same but different. Reinstate the students' ideas and concepts discussed, calling attention to important mathematics from the discussion. And then finally, we can generalise and apply. So we can ask students to create another same but different image that shows the same mathematical ideas. So it's important to notice in this image the word but. So we're not asking them to make a choice. You know, I'm going to prove that these are the same, or I'm going to prove that these are different. We're asking students to consider how 2 items can be both. And this is a really critically important distinction. Not the same or different, but rather the same but different. So I'm going to give you a couple of minutes now just to think about that. Now, if you were using this in your classroom, you don't have to go through religiously those 6 steps each time, but it gives you a framework to get your students used to the process, and then you might adapt it to suit. But I'm going to give you just a minute or so to have a think about it, and any comments that you have, either along the line of what is the same but different about these two, or how you think this might be useful for your learners. We have a few people having technical issues.
Yeah, I think so still no sound. That's not so good. I'm just wondering if there's the device settings. I'll just put a wee suggestion in with the device settings. That might help. I'm just aware if folk have sound issues. If we go silent, they'll not realise if the sound is working or not. So I'm just checking about if anybody does lose the sound at any point, one of the things you can do is click the three dots at the top and look at device settings and just click your speakers again, and sometimes that helps. So I'm just popping that in the chat as well.
Okay. Any thoughts on the images on the screen? What's the same about those two images but different?
And also just a wee reminder that the session is being recorded. So if you're happy having your video on, that's fine. But if you want to switch off, that's fine as well.
I'm aware that somebody's typing, so I don't want to move on too quickly. But one of the things that Iona and I mentioned earlier when we were looking at this is that they both represent the same expression, but the diagram on the right, I had to think about that there, on the right, kind of takes it a step further because it's almost beginning to start to solve and find a value for X. It's the first step towards solving and finding a value.
I think that's a really good observation in the chat. We've got a purely abstract representation on the left and on the right. I mean, it's a pictorial one, but it's also got that partly abstract in that you've still got the sort of miniature expressions of X+1. So it's nice, yeah. I have to say, oh, brilliant. I'm glad to have you back with us for the sound wax. Excellent. One of the things we've kind of talked about solving equations before using algebra counters, for example, to illustrate the sort of to pictorially illustrate an expression, the building of an expression or the solving of an equation. But certainly neither Nanette or myself, while we were teaching, had ever really sort of explored using bar models for solving equations. I wonder if there's anybody on the call who's seen that before or uses this kind of approach. And the other question Nanette and I were thinking about is, you know, if a learner put that working down on the right hand side, showed that bar model as they're working, and underneath finished it off with x equals 4. Which sort of follows on naturally from the fact that each of the X+1 expressions is equated to 5. Would that demonstrate an equal degree of algebraic understanding, a better degree of algebraic understanding? It's interesting that in Romania bar models are used. That's interesting. Good to know. So something to think about if you're teaching equations in the next few weeks, to think about looking at it as that as a representation to help learners just introduce the ideas.
And if you want to explore that site, there's lots of different sets of images there which cover all sorts of different areas of mathematics. It's not just algebraic, it's number, it's shape. There's lots to have a look at. It's definitely worth having a look at. And at that, I'm going to hand over to you, I think, Iona, to take us on to the next section.
Thanks, Nanette. So As you'll be sort of aware of now, if you've looked at any of our other sessions, we try to sort of think about some of the theory or research behind the ideas that we are sort of delivering in our sessions, and so I'm just going to sort of do a little bit about the sort of theory and some of the papers that are available to read on the sort of nature of problem solving. And there's a couple of links again on this slide here. Well, there's one to a PowerPoint that you might find interesting. And I think what we see on the slide here is the different aspects really to what it means to be able to use mathematics successfully. We kind of really like this illustration of mathematical behaviours from Mike Askew, who's a professor of mathematics in Johannesburg. And it's part of a really interesting presentation that we've linked on the slide. And it's on reasoning. And part of that is a fantastic quote that is that maths is not a spectator sport, and that's certainly one I've used a lot when I was teaching, and certainly when we're doing professional learning now, that it's something to really keep in mind. It's just so true. Learners really need to engage with their maths. They need to think, and encouraging them to think and helping them get better at mathematical thinking is a big challenge, but it's an important one. And in that presentation, he discusses how it's important that learners become fluent in the fundamentals of mathematics through varied and frequent practice with increasingly complex problems over time, so that pupils develop a really sound conceptual understanding and the ability to recall and apply their knowledge sort of rapidly and accurately. But they also need to be able to reason mathematically by following a line of inquiry, by making a conjecture, by spotting and understanding relationships, by being able to make generalizations, to be able to develop an argument, to justify their learning through proof or through a pictorial representation or through an explanation using mathematical language. These are all mathematical behaviours that learners develop with an increasing degree of sort of sophistication as they go through. And finally, that enables them to solve problems by applying their mathematics. And they need to be able to do this to a variety of routine and non-routine problems with, as I say, an increasing degree of sophistication. And these are the techniques they might use are things like breaking down problems into a series of simpler steps, and also persevering in seeking solutions when they become stuck. So it's that determination to keep going, even if they're finding things difficult. So there's loads in that, and it is maybe quite a worthwhile presentation just to have a wee look through, and just to see what Mike Askew's kind of view is on the nature of mathematical behaviours and problem solving. And so it is true that you need a degree of procedural fluency, mostly to ensure that you've got enough space left in your brain to think about a strategy for solving a problem. But underpinning that fluency, it's not enough to just have procedural fluency. You have to underpin that with a good bit of conceptual understanding. So you know what the maths is for, and you know what the purpose of it is. If you understand the maths, you've got a much better shot at applying it in the right context. If you don't understand the maths, you're going to struggle to know when it's applicable. And finally, there's that bit of mathematical reasoning. That's that ability to see links, to spot patterns, to apply the skills you've learned previously, and to see when solving a new and unfamiliar problem, you can apply what you've learned before. To illustrate the importance of problem solving and its nature, we've just taken a couple of quotes from a really useful paper that we've linked to here. It's the Generation Ready article, the bottom right-hand corner link. It's Generation Ready is an educational consultancy based in New York. It is worth a read. It's quite a short and easy read. And that first quote there about our students living in an information and technological based society, which means that they need to think critically about complex issues. They need to analyse what's in front of them. They need to think logically. They need to be able to apply that to new situations, to find solutions. And they're not finished when they found a solution. They've got to be able to communicate that clearly, that solution to the problem as well. So the article really describes the importance of mathematical skills in this technology-based society that we live. And I think that first quote sort of illustrates it quite nicely. There's a lot of information out there from a variety of sources talking about 21st century skills. You'll see lots of variations on these. But there's quite a lot that links into mathematical behaviours in any of these lists that you'll see. So this idea about thinking critically and logically, to be able to be organised and sort of organise your thoughts into a coherent argument, to be able to process information. Those kind of things are sit quite naturally in numeracy and maths, and I think it's not a big stretch for us to realise that we are going to contribute to these a lot if we choose activities that really make our learners think. And so taking all that into account, the challenge for us as teachers is to consider how can we sort of maximise the opportunities for learners to develop their mathematical reasoning alongside developing proficiency in mathematical techniques, because that is still important, but it's not the be all and end all. And most importantly, how can we embed that in everyday practice so that learners and ourselves don't see problem solving or mathematical behaviours as something separate from what we do every day. It should kind of be integrated together. So that's probably the big challenge. If we're talking about the place in the Scottish curriculum, there's no specific curriculum organisers or experiences and outcomes linked to problem solving, because problem solving really needs to be embedded across our mathematical experience in all areas of the maths curriculum. It shouldn't be seen as a separate entity. But where mathematical skills and mathematical behaviours are outlined is at the start of the benchmarks document. And it describes this kind of list of mathematical skills and behaviours. Now, I should stress this is not an exhaustive list. There are others that we would want to develop as well, but it kind of gives you a sort of starter list for some of the skills that we want learners to develop. And as it says here, learners should as they move through the levels, they should demonstrate an increased sophistication and level of independence in a range of increasingly more challenging contexts that learners are going to develop these. And the section after the list kind of breaks down each of these skills and just gives you a bit of additional guidance as to what that might look like at sort of different levels and how learners might progress in their level of sophistication in these skills. So if you haven't looked at that section of the benchmarks in a while, or maybe not at all, it really is worth a read through. And it's worth bearing it in mind as we're sort of upping the ante of level of mathematical thinking in the activities that we're doing. Why are we doing it, and what's the reasoning behind it? And you'll find a lot of that there in that document. Again, quite a short read, quite readable, quite straightforward. Hopefully you will find it helpful. We're going to watch a little video now about what Dan Finkel, who's in this video, is a maths educator from across the pond, describes as the productive struggle. We love this video, and there's lots of great stuff from Dan online and on Twitter. He is worth a follow if you're on Twitter. We're going to, I'm hoping that we won't have any technological issues and that you'll be able to watch this video, or you'll be able to hear this video as a click play, but the link is on the slide as well. So this is about 3 minutes long. We're going to watch it. This is Dan talking about the productive struggle, and I hope you find this video helpful as well. So fingers crossed, if maybe somebody can give me a thumbs up when we play it, hopefully this will work okay.
Hi, I'm Dan Finkel, and I'm a math educator. One of the things I get really interested in is what is the skill that's actually developing as students work more and more deeply in mathematics and go longer and longer in their careers. And I think there is one metric that explains almost the whole thing. And it is, how long are you willing to be stuck on a problem? And what I found is, young kids, maybe they can be stuck for 10 seconds or 20 seconds, maybe even a minute or two. And if they're really involved in like a playful experience, maybe even 5 or 10 minutes. Play kind of extends our ability to do this. As we get older, I don't know, maybe in grades 3 and 4, you might see 5 minutes, 10 minutes. And ideally, In the upper grades, you're going to see students increasing that to a half hour, an hour. By the time I was in graduate school, I feel like I was ready to spend a month stuck on a problem. And by the time you're a professional mathematician, maybe you need to spend many months or even years stuck on a problem. It is your willingness to be stuck in the productive struggle that defines how powerful you are as a mathematician. That is just one of the key components to the whole game. So here's the deal. We need to teach that, because if you're not teaching that, you are not helping your students to become better mathematicians. And what that means is you have to teach them to persist, to persevere, to struggle in a productive way, which means you have to give them the time to struggle. And this is the hardest thing as a teacher, because there are so many demands on your time, so many learning targets, so many things, and yet it is maybe the most critical thing to defend, to say there needs to be a time where my students can just dig into a problem that is worth doing and see if they can go longer today than they did the previous day. Get a little bit further before I step in to help them. Give them that time to extend themselves as problem solvers. I've seen students who go through school, and the longer they're in school, the less willing they are to spend time on a math problem. They're learning the opposite lesson that they need to learn, if that's the case. If you're less willing to spend time on math problems, if you see them as things you should just either know the answer to or you shouldn't even bother doing them, that is the opposite lesson we need to teach. We need to give students time to struggle and help them engage and extend themselves to become more persistent, more perseverant.
We love that video because I think it's something that really resonated with us as really experienced maths teachers. Those kind of pressures that we face day in, day out in the classroom, and whether we feel that we get the time to do that. Just any reflections on that? Any comments? Anything that you feel about that video that resonates with you? Do you want to just pop that in the chat just now if there's anything that you think, yeah, I totally get that sits for me? Do please just pop that in the chat. While you're sort of looking at that, yeah, there's a comment saying that I can agree. His comment that we don't see the resilience to problem solving, and I think that's an important point, that when we are asking learners to think really deeply about a maths problem, the solution to that problem needs to involve maths that they are very confident in. So if we have learners who are working within second level maths and they've learned some new second level maths, or maybe some third level maths, we can't give them really tricky problems on the maths they've just learned last week or last month. We need to give them tricky problems on the maths that they've learned a while ago, and then give them more simple and more standard problems on the stuff they've learned more recently, and develop, because if they're still having to think hard about the maths, they won't have space left to really think hard about the problem solving aspect. So maybe that's just something to think about. And and that's one of the ways we can build resilience in problem solving, is actually get them to think really deeply about maths they know well, rather than getting to think really deeply and solve tough problems on stuff they've only recently just learned and are maybe still not very confident in. A willingness to struggle for longer does tend to be something the more academic students, people, and it's also maybe not so much that, it's about learners who are really interested in numeracy and maths. It's their thing, that they really, that they've really come to an enjoyment of it, and they've got that desperation to work it out. It's like, they've got a bit between their teeth to do that, and you might find other learners might very much have that resilience in a different part of the curriculum, or a different on a different or in a different area of their lives, that they're really tenacious in an area outside school. And it's how can you take that tenacity that they've already demonstrated in somewhere else and actually say, no, you can do this in maths as well. You can be that in maths. And I think the key to that is get them to think hard about stuff they know well. And that gives them more likelihood of getting, building that tenacity in maths as well. Just a couple of notes of caution on this slide here. If we are, quite often we sort of think about keywords and key phrases that help learners attach a piece of maths onto a problem. There's just a couple of health warnings with that. So in problem solving, learners really need to be able to understand the context of the problem and visualize the problem and really internalize the problem, not simply just look for keywords and kind of pattern match. Additionally, some particular keywords can actually end up being used for more than one type of operation. Particularly these days when we encourage learners to investigate different ways of solving calculations. For example, finding the difference between two quantities. Learners can use a subtraction as a count back to do this, or they can solve by counting on. And so we need to be clear that learners can think about it in different ways, and for them to not be too fixed about a keyword sends you towards a particular thing. I mean, this continues right up into higher maths, for example, where we might use calculus to find the equation of a tangent to a curve, but we're using geometry and algebra to find the equation of a tangent to a circle. And so we need to not fixate on the words, find the equation of the tangent to. What we really need to make sure is learners understand where the gradient of a tangent comes from in calculus and where it comes from in a circle, and how we're finding the same thing, but we're having to really understanding why there's different pieces of maths apply at higher level as well. Word problems tend to be complicated in part because of the descriptive language that they use. Students often don't understand exactly what they're being asked, especially when the problem actually includes quite abstract concepts. Other issues arise when students lack the fundamentals of the maths that they're needing and can't formulate a plan for solving the problem, or can't sort of separate it into steps that will enable them to get to the answer. We all know the strategies that are used within our schools. So, for example, we might say draw a diagram or a picture, act it out, rephrase it in your own words. These are really crucial, and it's important that learners are given time and space and structure, and that we model these problem-solving strategies so that learners develop a wider range of strategies there. So on this slide, there's a number of reflective questions that you might think it's worth coming back to when we have the slides from the ThingLink, and thinking about, how can we do this in the classroom? These are some interesting questions to answer, and they're not straightforward to answer as well. So you might find these useful to reflect on your own practice as well. So for the rest of the session, what we're going to do, that's the theory over. We're now thinking about that theory in practice. What can it look like? How can we do all of this? How can we give our learners opportunities to really think deeply about their maths? So these are some of the strategies that we're going to look at. We're going to look at open-ended and open-rooted questions, slow reveal graphs, more same less problems, asking learners, are statements always, sometimes, or never true? We're also going to go the whole hog and look at goal-free problems, and some same surface structure, different deep structure questions as well, and some classic problem sources. So are there any of these that look familiar to you? Are there any of these that you've done before or that you've come across before and tried with your learners? So just so that we get an idea of what we might spend slightly more or less time on, any of these ideas that people are already familiar with, and we might just cut down a bit of the time on that. So just pop any in the chat that you've already done. And if there's none of these that you're familiar with, then just pop in the chat none, and we know that these are new to you. Hopefully everybody's, so we've got open-ended questions, that's where we start. So had a bit of use of that already. And for anybody watching the recording, this is the kind of order that we're going through things in. So you might skip forward or backwards if it's things that you in the recording if you've already seen some of these things before. And so we've got some
Same surface.
Yeah, and open-ended. So open-ended seems to be the ones that more people have looked at. So we'll start with that. Not sure what slow reveal graphs are. That it's they're not that commonly known about. They're just quite lovely. So it might be an idea of something that you might want to try with some of your learners. Great. So, and goal-free is not something that you've tried much. I think goal-free problems is one of the options that could be the most powerful actually of all these ones, that might help in developing resilience as well, but more of that later. Okay, so open-ended questions. These are questions which are great for learners, because I think quite often learners think that the only thing that makes maths different from anything is that there's always one answer and it's right or wrong. And I think what we want to do is challenge that with learners. There's lots of maths questions that have lots of different valid solutions. And they have, if we ask more of these, this gives us more opportunity for equity, because the different learners in the class who might be working at slightly different levels can access these questions at a level that sort of suits them. It can ask learners to encourage them to be a little bit more creative and employ some more of their higher order skills. And does really give the opportunity for assessment, because you can see where learners are at rather than seeing whether learners can do one specific thing or not. So we've given just some simple examples here of questions at second level and third and fourth level that are more open-ended. So rather than here's a question with one specific answer, we could say, for example, we add two fractions together and the sum is 3/8. What could the fractions be? Learners might start with very simple calculations that give the answer 3/8. They might end up chucking in some negative fractions. They may well have to use some equivalent fractions. They may well, start to, they might only be able to come up with one or two, but then maybe with discussion with a partner, they might be able to suddenly realize, oh, there's more to that than this. And it doesn't have to be fractions, you could be using decimal fractions, or you could be doing expressions or various things. There's lots of things you can do that, but it's basically a type of question that's, here's the answer, what could the question be? And the next one there, the solution of an equation is x equals 3. What could the equation be? It's an algebra version of a very similar type of questions. So here's the answer, what's the question, is a classic sort of question that we can ask. They may have an infinite number of valid solutions, or they might actually have a fixed number of solutions. If we look at the second level question, together 3 children have £26.89. What coins or notes might they each have? Now there will be a finite a number of answers to that, but there'll be an awful lot of them, so they're unlikely to find all of them. But the question is, could they be a bit systematic? Could they maybe get any insights into how they might put that together? Might they start with, some children have whole pounds and then one of the children has 89 pence? What's going on here? There's lots of different ways that learners could explore that. So if you're interested in open-ended questions, or you maybe tried them before, you want to do a little bit more on that, we have a little mini guide that's on our professional learning community site, and there's a link to it there with some more examples and places you can look for further inspiration. And similar to open-ended questions, we've got these open-rooted questions. We've taken this from an excellent site called Open Middle, and there's questions on Open Middle from the very earliest stages right up through to kind of high school maths. It's an American site, so be aware that you've got it's the American curriculum, so the grades won't match up with the year that you're teaching, but they are really interesting. And here's where they're are a number of different routes, usually to a target solution or an optimal solution. So learners might not get the optimal solution, but they can explore lots of different possibilities along the way. And then they can, there's a bit of refinement there about from wherever they start. They might just start with a stab in the dark and then try and refine it and refine it and refine it until they kind of get to a more optimal solution. So this example here is, and a lot of the open middle ones are very similar. Learners have to use any of the digits 1 to 9, but they can only use them at most once. So they're picking 4 digits out of the 1 to 9 digits and place a digit in a box to create a solution to the equation that's as close to 0 as possible. Now, if nothing else, learners will make up a few equations and solve them and get some answers. So at the very least, they'll get some practice at solving equations. So part of the purpose of this is that they're going to get some practice at solving equations with x's on both sides. Fine. But the mathematical thinking that goes on the top of that is, how do they refine their equation to get a solution that's close to 0 as possible? So they're starting to think about patterns and relationships and aiming towards a solution. And this is where they're starting to develop a strategy and kind of get more generalized thinking based on some fairly specific maths that they're doing. So definitely worth having a bash at some open middle. If you've not seen them before, that is definitely a site that is worth a rummage because there's lots of really nice challenges for learners. Simple maths, lots of thinking. And maths right down to kind of very basic addition and subtraction, but lots of deep thinking that's going on the top of that. And if you gave the same challenge to learners at different stages, you might get quite different responses and quite different approaches to it, which is nice as well. Right, that's me. I think I've gone on long enough. I'm back to Nanette, who's going to take you through some slow reveal graphs.
Thanks, Iona. So these are sometimes also known as notice and wonder graphs or numberless graphs. And so the graphs are gradually introduced one step at a time with a little bit more information added at each stage. Time's given to discuss, to think and to wonder at each stage, and it's important that you do give your learners enough time to actually really think about it and to respond at each stage. And as more and more of the graph is revealed, learners begin to refine their interpretation, and often they can come up with, it changes quite significantly from what they initially think they're seeing as more information is added to it, and they can come up with some quite surprising interpretations. So before, we're going to have a look at an example here, which is taken from the website, which there's a link to on the slide, but it is important to point out again that this is an American site, and so some of the examples are very American-centric, so they won't all be appropriate, but it gives you some good ideas, gives you a starting point, and then it's actually quite easy to put something together yourself. It can be used in the same way. Sorry, you just have noticed the cat tail went in front of my face there. So in this one, we've got 4 related box plots. So you might ask your learners, what do they notice about the samples? Do they notice that some of them are big samples, some of them are smaller samples? What do they notice about the measure of central tendency? What do they notice about the spread? And I think just to get a kind of feel for how this works, it might be interesting if you put your thoughts into the chat. So what do you notice about the 4 related box plots? What do you wonder about it? What do you think? Just relating to any of the things I mentioned there about the sample size, the measures of central tendency, the spread. I'll just give you a couple of minutes to put your thoughts into the chat before we move on to reveal the next little bit of information.
There's lots of typing going
on. I know. But it's that idea that you have to give your learners time to think and to formulate their thoughts. And it's one of the things I've got to say I find quite difficult. Oh, I can't see them very well. The
You
yellow and
should
red
be able
graphs.
to view them on full screen if you click the three dots. So like the central tendency has moved downward on each graph, so it goes successfully. So the pink one has got the highest median, followed by the reds, followed by the blues, followed by the orangey yellows. Anything about the spreads? The yellow and red graphs seem to have a larger sample size than the other two, like that. Yep. But it's tricky to see, certainly. Anything else? And I don't think anybody else is typing at the moment, so we might need to introduce some more information.
Yes. And at the back of your mind, you might be thinking at this point, so what is it that this represents? Because that's the general idea is for you to try to work that out eventually. But at the moment, we're looking at that. So let's introduce a little bit more information. So we've got heights. But heights of what? Could be people. Any idea which specific group of people? So again, I'm going to give you another minute or so to just think if there's anything that you notice now or anything that you would like to add to your observations.
I think what's nice about this is the importance of an accurate scale on a graph really comes at if you don't have one there and then suddenly you do have one, they suddenly say, right, now I can actually put a handle on what that information is actually did.
Probably adult males due to the range. So now I would be thinking, well, is it a particular group of adult males? What's this graph actually representing? I can see there's some. I don't want to move on before the next additions appear in the chat.
And this is where your learners might get quite creative and they might come up with 4 random groups of people and what they might, why it might be them. Is the pink graph full of basketball players? Interesting. Yes.
Outliers at the top are quite tall. Yep.
Absolutely. And I think outliers are something that learners are quite interested in spotting. Tallest, shortest, yep, great.
But it also highlights that, looking at it really quite closely and thinking about, so we've made the assumption that it's heights of adult males, so that means we have some quite tall adult men there, thinking about what outliers actually means in the context of this graph. Okay, I think we might need to add another bit of information.
This is quite small, sorry. So if you can't read the title there, it says distribution of height by position for each player in the 2018 FIFA World Cup. Okay,
so we did have somebody earlier who mentioned basketball players, so it's not basketball players, it's footballers. So they've been split into 4 individual groups. So the next thing to think about might be, how have they been grouped? What do we think? And which group might be which? Oh, goalkeepers, defenders, midfielders and strikers. Goalkeepers, defenders, midfielders, okay, and attackers, okay. So in that order, Mr. Parkinson and Mr. Dolan?
Here's when we're hoping nobody skipped forward and looked at the slides. See, that's the only downside of having a PowerPoint Live where you can skip forward through the slides. In that order, you'd guess, are they right? They do agree. So that's 2 people agreeing on it. So that'll be interesting to see. Shall I click the button?
Mr. Parkinson is still typing. I'm just waiting to see what he's going to say before we do the big reveal.
It would be strange to put it in another order. Oh, interesting. So guessing so.
Okay. So have we revealed? Oh yeah, we have. Sorry, it's quite small for me as well.
Yeah.
So goalkeeper, defender, forward, midfielder, goalkeeper, defender, midfielder, and striker. So I would say the last two are in the opposite order from what the guess was.
Maybe a reflection herein is that is maybe the sample size helps with the last two data sets, in that there's probably more players classed as midfielders than there were as forwards potentially in the squads. So that might have helped differentiate. So it's not just about the heights, it's potential, once you know the context, it's potentially more about or also about the sample sizes too.
Mm-hmm.
So although they've been ordered by mean height, median height, I guess, that the sample sizes are slightly different or appear to be slightly different. They're quite hard to put a number on it, but number of dots maybe helps.
So, you know, this process just allows learners to focus on one aspect of the graph at a time. And so it gives them that extra time to try to understand its significance. And also just that idea about giving them opportunities to make conjectures. There's a variety of different types of graphs that you can find on the site. We've used examples before which have been bar graphs, line graphs. But once you've seen a few examples, then you can see how you could take a graph that you've got and just, you know, take some information off and add it back in. So I think it's a really nice way of just getting them to think about the interpreting it, which is often the area that learners find quite difficult. So maybe that's something that it's worth exploring a little bit further and having a try at. So I think we'll move on. There's some typing going on, but I'll pick that up. Oh, good, Jennifer, great. So the next thing I'm going to have a quick look at is more same less grids. And these are just a good way to try to make sure that learners are thinking while they practice rather than just mechanically repeating the same thing. So we start with a given centre object, and then pupils have to try and make the smallest change possible to complete the other boxes. They've got to change one aspect to the central object while also having to maintain a particular aspect. So this means that learners have to attend to how changing one aspect of the centre object changes another, meaning they've got to think about how the change they're making affects the second property. You know, what changes and what stays the same. So an example of this might make it a bit clearer. So in this one, I'm just
going to take that, sorry, I'm just going to, is that work? Are you just seeing the 30 now?
Yeah.
Okay. Right.
So here's an example using multiples and factors. So across at the top, the first aspect is the number of factors, down the side is the value of the number. So we're given a starting value of 30, and we're looking to find greater and lesser values that have more or fewer factors. So learners would start by listing the factors of 30, of which have just popped up, and you can see there's 8. So that then what we're asking learners to do is to fill in as many or all the other boxes. Some of them they may not be able to put anything into, but they're going to look at filling in all the other boxes. So let's start with looking to choose to increase the value. So the first box, you know, so the value is going to be more, but it's going to have less factors, and they want to make the smallest change they possibly can. So they might choose to increase the value to say 31. Because since that's prime, it's only got 2 factors, and that can go in that top left-hand corner. So bigger value, fewer factors. Then we could look at the box on the right-hand side. This time we want to increase the value and have more factors. Well, that one's quite straightforward because any multiple of 30 would do. So, you know, in this case I picked Oh, you've gone down.
Sorry,
We're going to,
sorry, the animations are a
the
bit weird.
animations are a bit weird.
Yeah.
So I'm going across to the top corner. It's because that's a nice straightforward one to get. You know, if I double it, then I'm going to have more factors. So I filled that one in, that's 60. Looking at the centre in the top, that might take a little bit longer to find one which has got the same number of factors but is a higher value. So that might take a little bit more time to actually think through and find something to put in there. Looking at
Sorry.
that middle row, well, if we keep the values the same, the number of factors can't change. So we've got 2 slots here that are impossible to fill. So, you know, but that in itself is, you know, quite an interesting point for your learners to think about. You know, if you don't think you can think of it, why can't you fill anything in there? So then looking down to the smaller values, well, again, 1 less than 30, 29 is also a prime, so it's pretty straightforward to slot in there too. And then we could go on and fill in the rest of the grid. But I'll stop there. So there's a number of sort of insights about prime and composite numbers that can be gained and discussed by working through this activity. There's lots of mathematical reasoning, but all learners with some sort of basic knowledge can give it a bash and can give it a try. So it's a type of activity that most of your learners will be able to access in some way. You can give your learners a chance to explain their reasoning. You can ask them to repeat or amend it using a different starting numbers. You can talk about the strategies they used. So, you know, when I mentioned the fact that they would just, if you doubled that 30, then you're going to have a larger number and you were going to have extra factors. You can, you know, think about what kind of generalizations can be made. What other solutions could you find? And how can they be sure that if there's a section that they don't think can be filled, really can't be filled? So there's quite a lot to be gained from just that one activity. On the next slide, there's another example. This one's probably a bit more straightforward than the factors and primes one, but it could be used alongside a bit of practice in sketching the graphs. On the same axis, just to reinforce what they actually look like and to make that clear connection between the graphical representation and the symbolic representation of the graph. Okay. So the final one that I'm going to talk to you about is the always, sometimes, never. So these are a great opportunity for learners to use reasoning to decipher mathematical statements. So we often make mathematical claims that are only true in certain contexts, and it's important for learners to be able to look critically at statements and to understand in what situations they apply. So you might want to start with one statement and have a bit of a discussion around the class, you know, allow them to have a bit of time again to think on their own, to discuss with a partner, and then pull that together as a class about whether they think it's true. So ask them to give you some examples to illustrate that the statement is true, and then to decide whether it's always true. If they decide it's true, you could think about what the conditions are. Are there any conditions that need to be set to ensure that that's the case? Is there any conditions that would mean that it wasn't always true? So you could also have a group of learners, and you could give them a set of statements, and they could then sort that onto a grid under the headings of always, sometimes, and never. They could do it physically, or you could do it digitally. You would ask them to justify their reasoning, and if they think it's always true or never true, you can ask them to really dig into this and explain why they think this is the case. And if they think that it's sometimes true, then they could start by coming up with cases for each and then try to generalise and look at what the conditions are that make that the case. So that's just a couple of examples of activities that you might want to think about and try. These tasks, there's some more information around them on the Enrich site, and again, the link's there for you to have a closer look at after this afternoon. And I think I'm passing back to you, Iona, the next section.
Yep. Thanks, Nanette. So we talked about open-ended and open-rooted problems where you ask a question which has got a number of different valid solutions. Well, you can go one step further and just kind of not ask a question at all. And that is going the whole hog and going goal-free. And this is where you give a provocation for thinking, or a scenario, or a set of information, or a graph, or whatever it happens to be. And you basically don't ask a question other than to say, what can you work out? And this is really helpful for learners to kind of come to grips with what do they actually know about what they know? What do they know about what applies here, and what bits of learning can they take from something that might be really simple that they learned a long time ago right up to something that they learned quite recently. So there's, in the same way as open-ended questions have a lot of opportunities for equity and learners at different levels accessing them, and also for you to have a bit of an assessment opportunity to see where learners are at. Go Free has all of that as well. But also it has the added benefit of a bit of reduction of maths anxiety as well, because quite often, particularly as we go on to multi-step problems and we go on to more challenging problems, in order to successfully overcome that problem, learners have to know almost in advance what all the steps that they're going to have to do, and they need to then be able to carry them out correctly in order to get to some definite answer that they are looking for. And that can be quite daunting for people and kind of contribute to anxiety. Whereas if you say, what can you work out? Then there's every likelihood that the learners are actually going to get to the nitty-gritty of what you hoped they would get to, but lots of other things along the way. And they'll have a thought about, they've been thinking about, so what can I do? Not just, can I do X, Y, or Z? Here are all the things that I can do. Learners may start, the very first time you give learners this, they might need a bit of peer support, a bit of modelling, doing it as a sort of big group, and a bit of discussion around what types of things might we be able to find out, what types of questions might we be able to ask. But the learners are able to be a little bit more creative because they're thinking about their own questions and trying to develop their own understanding of what types of things might they be looking for in these situations. There's a couple of papers there, a couple of articles there about that kind of justify or think about a bit the theory behind why goal-free problems can be really helpful. And this is just a simple example. Here's a really simple bar chart. What could learners work out? Now, if you think about a standard textbook exercise on bar graphs, if we think about what questions, question 1, part A, B, C, and D, B, what's the highest? What's the lowest? What's the difference between the highest and the lowest? What's the total of all this altogether? Do we need to ask these questions specifically? Or could we actually just give them the graph and get the kids to come up with that for themselves? And I think as learners more and more get used to this kind of idea, they start thinking about what are the key things that I want to know about that graph? What can I work out? So there's an example of just a simple sort of first level bar chart. So it can start, it can be done with very straightforward maths, or we can look at some examples. Past paper questions at all different levels is also a really, really nice thing to do. And so we've got a sort of Nat 4 level, we've got measurements of a cylinder. What could we work out? So we don't just need to ask them about working out the volume of a cylinder. We can just say, what can you work out for that? So for example, they could work out the diameter, they could work out the circumference of the base, they could work out the area of the base, they could work out the volume of the solid. There's all these different things. And there's a real added bonus here to my mind, and that is learners have to be really clear about what it is they're working out in order to frame the question by themselves. Whereas quite often learners, particularly if they're kind of struggling at Nat 4 level, for example, they might just look at that and go, it's a cylinder, so I'm going to have to work the volume out. And they've maybe not read the question or checked whether or not that the question is that. Or they might think whenever they see a cylinder, the only thing they can work out is the volume. There's a lot more to it than that. There's lots of things that learners can work out. So we want them to be clear about what it is they can work out and work together on that. So by going goal-free, they're not fixating on one particular thing that they do. There's lots of things they can do. The second example there is from a higher paper. It just says that it gives 2 points on the circumference of the circle and states that the line between them is the diameter. And I sometimes sort of think when learners are doing straight line or they're doing polynomials or they're doing circles at higher level, that they quite often fixate on this is how I do this is how I do this, and this is how I do this. They don't really think about what it is they're actually doing, and they certainly don't see the links between all these different little mini skills that they can do and how they can combine those little mini skills in order to work out more complicated stuff. They see it as all separate when in actual fact it's all tied together. And maybe by just saying, right, here's a circle, what can you work out? And give them it in pairs or groups of 4 or whatever it is, and they can maybe do a bit of divide and conquer. They could do, well, I can work out that and I can work out that. And then they might see, oh, well, but in order to work out that, I need to know what you've worked out and I need to know what you've worked out. So actually, there's some simple things that we can work out, and then we can take those simple things and use them to work out more complicated things. There's all that kind of understanding that can go with this. Now, obviously, you would kind of need to do this towards the end of when they've encountered all the different things that they can do with circles. But it's a lovely revision task. How to add value to your past paper questions is take the questions off. It's just give them the diagram and say, what can you work out? Then they revise absolutely everything that they know about circles rather than that one individual thing. And then you can give them the aha reveal moment when you actually slap the question back on the board and go, this is what it actually asked you to do in that higher paper that year. Did any group actually get to that? Did any group actually find that out? But see this one diagram in this question, that wasn't the only thing that you could have worked out. You could have worked out all this other stuff as well. And you used all this other stuff to find out all this other stuff, and it just ties it all together a wee bit more. So I think goal-free problems is one of the things that actually could give you a massive bang for your buck about getting kids to draw the little bits of maths together that they know and get them to be a bit more aware of the totality of what they know and how it all interlinks, rather than it just all being viewed as separate things. Something to think about if you've got a higher class or you've got a Nat 5 class at the moment. Have a bash at something they learned maybe back in August, September, and something they've practiced a bit in homeworks and they're a wee bit confident with now. Give them a goal-free problem and see where they get to with it. It'd be really interesting. And, you know, if there's a particular question that works really well, or lack of question thereof, you know, come back to us, put it in the team chat and let us know about some really specific examples that worked really, really well with your learners. Good to know that and good to share that with each other. There's a couple of folks saying that they've tried that or they like that idea. So it'd be good to hear how you get on with that if you're going to try it. There's a wee mini guide. We have many mini guides. There's a wee mini guide about goal-free problems as well, and there's a bit more information, a few more examples and things like that on there. Same surface structure, different deep structure is one of the Craig Barton sites, and Craig Barton podcast, his books are all very much a really good professional learning in there as well. There's a number of sites that he has that are of use to secondary maths teachers, and this is just one of them. This is about selecting a strategy, and I talked a little bit before with the Nat 4 cylinder question about why, you know, learners quite often just word grab. They don't read the totality of the problem. They just kind of word grab and go, oh, it must be that, and that's what I'm going to do. And this can be problematic if we get problems that are quite similar. And what learners have done is they've answered the question they think they've been asked, not the one they've actually been asked. or they've misapplied a strategy because they kind of just not got that deep understanding of what applies when. So this is a nice way to do it. You can get collections of problems that look quite similar, but actually require quite different maths in order to solve. On Craig Barton's site, SSDD Problems, there's loads and loads and loads of examples, and they're kind of grouped by topic and grouped by level. And so if you have got learners that kind of word grab and sort of don't really think deeply or jump right in without really thinking about the question, these can be quite nice to get them to just stop, think. How are those questions similar? How are they different? It's that same but different idea going on, these comparisons, and get them to think carefully about what's different about the way that we need to solve these, even though the problems look as if they, on the surface, look as if they're quite similar. Some might be quite simple, some might be quite complicated, some might use completely different maths, even though they look kind of similar. So there's a few links there as well. We've got a mini guide again about that one. So and there's a blog site about it as well. So if you're interested in doing that, again, it may well be quite useful for learners as well. We are aware we are chucking loads of ideas at you at the moment, by the way. We should have put this health warning in at the beginning. Please don't feel that we're suggesting you should be doing all of these. Take one or two ideas, the ones that you think your kids would benefit most from. Take one or two of them, have a bash, see how you get on, have a wee reflect on it. Don't give up at the first try, by the way. Persevere for a bit and see how it works out, and then have a wee reflection on what did the kids get out of it. Ask them, what did they get out of it, and then kind of keep in your teacher toolkit the ones that you think work best for you. Just a couple of more ideas. I am aware that we're getting to 5:10 already, and we've still got a couple of ideas left. Mathematical behaviours. This is kind of important as well. We talked about the skills and the benchmarks. There are mathematical behaviours and problem-solving types of strategy or types of problems that occur again and again and again at different levels. And we want to make sure learners have had the chance to develop these mathematical behaviours, like trial and improvement or guess, check and improve, what you might ever call it. Have a first stab at the dark at your, how good is that solution? How near is it where we're looking for? Can we improve it? Can we hone in on the solution to the problem? There's lots of problems that can be solved that way. Can we give learners a chance to experience those, and can we model them ourselves as teachers, or can we get all the learners to model and explain how they tackled it as well? It gives learners the chance to see how different problems that might look quite different can actually be solved in quite a similar way. There's these ones are taken from the Enrich site. The mathematical behaviours that they've got are trial and improvement, working systematically, working backwards, visualising, throwing a picture to visualise what's going on, reasoning and convincing, so that's being able to kind of generalise and being able to explain your reasoning as to why that is, and producing a convincing argument, and then conjecturing and generalising. So making a conjecture and testing that conjecture and making a generalisation. These are all laying the foundations for mathematics at its kind of next level up. These are kind of key stage 2 level ones, so kind of upper primary, lower secondary. There's loads and loads of interactive activities on Enrich. If you follow that link, you'll see there's little challenges grouped around these kind of mathematical behaviours, and you might find them useful for maybe your lower secondary learners to have a wee bash at some of these problems on Enrich and give them chances to develop these strategies and put them into practice and compare them with each other. One last source of problems for you, we plug this regularly. Don Stewart's Blogspot is just the most amazing collection of lessons, of tasks, of problems and puzzles, and just brilliant, all grouped by level and by area of mathematics. The link is on the slide again. Just one that we've highlighted here is looking at sort of some of these classic mathematical problems and thinking about how they can sort of extend a pattern to solve a problem and that kind of thing. So we just can't recommend that enough. There's some beautiful lessons and some beautiful tasks there that will get learners thinking, and I can't recommend it enough as well. Absolute little treasure trove that one is, and hopefully you will find some things that your learners will enjoy in that. Right, I think we've chucked enough ideas at you at the moment. We are going to stop there, and I'm going to hand you back to Nanette.
Thanks, Iona. So we are aware that we threw lots of information at you there, and we've listed lots of links, etc. All the links that we've mentioned tonight will be pulled together and put on a thing link, which will contain the recording of tonight's session, and direct you to where you can find the links. But you can also go to the PLC. If you go to the Developing Mathematical Thinking, then there's also links to lots of these websites there, and that's worth an explore if you're looking for something different as well. What we would like to do before we come to an end tonight is to ask you to take a few minutes to think about our final live session, which is in May, 16th of May this year. Now, we haven't got a firm plan for what we intend to cover in that, because we want it to be responsive to those that have undertaken the programme. So we will be gathering thoughts from everybody that's engaged in the programme, as well as those that have been able to join tonight's live session. But we'd like you to take just maybe 5 minutes or so to click on the link on the screen, or use the QR code, and that will take you to a form which gives you the opportunity to give us some ideas of what you would like to focus on in that final live session, and also to just give us a little bit of feedback about this afternoon's session and about the programme in general. If you are watching this in the recorded version, you can also give us the feedback using the same form. So again, I would encourage you to use the QR code to go and give us that feedback. If you're watching the session after the end of March, then you won't be able to give us ideas for the final live session, but we would still really appreciate any feedback on this particular session and the programme in general. So I'm going to stop there for a few minutes, allow you to go and access that form, and then we're going to come back and just give you an opportunity. We'll stop the recording and give you an opportunity to have a think about some of the things we've talked about this afternoon, and ask some questions and just to reflect on the things we discussed.